Okay, so now we're going to do a couple example problems involving the first derivative test. So it says to find the relative extrema of the function f of x equals 1/2 x minus the sine of x. So we're looking on this interval 2, we're looking from 0 to 2 pi. So the first thing that we have to do here is we need to find what our derivative is. So we get f prime of x, you should get 1/2 minus the cosine of x. And we're looking for when that's going to be 0. So we're looking for our critical numbers, any critical number which is 0 or undefined. So we get f prime of c to equal 1/2 minus the cosine of c, and then it all has to be 0. So we're going to go about solving this. We get 1/2 equals the cosine of c, and so this will occur. Cosine will be 1/2 at pi over 3 and 5 pi over 3. So we need to look at our derivative around these places, around these points. So I'm going to go over here. Just a little further down. And we've got pi over 3 and 5 pi over 3. And what we want to know here is our derivative positive or negative around these parts? So we go back to our derivative, which is 1/2 minus cosine of c. So we need to decide positive versus negative. So let's pick a test value here. So let's say we'll pick pi over 4. Well, pi over 4, if we pick that, the cosine is going to be larger than 1/2. If we think about your unit circle, pi over 3 and 5 pi over 3 are here. Cosine's larger this way. So we are going to have a larger value of that, which is going to be 1/2 minus a larger value would give us a negative. Then we need to pick a number between pi over 3 and 5 pi over 3. Why don't we pick good old pi? It makes it easy. So the cosine of pi is -1, so this would be 1/2 minus -1 will give us a positive. And then after 5 pi over 3, we could pick 11 pi over 6, or well, when we pick 7 pi over 4. Be consistent. These are the same. So they're the same cosine, so we're going to get a negative here. So we have going on, or we do have 2 points. One at pi over 3 and one at 5 pi over 3. So the big thing you want to do with these is you want to find what the actual coordinate is. So pi over 3 is the x. So what happens, so if we plug pi over 3 in, you should get 1/2 times pi over 3, which would give us pi over 6. And the sine of pi over 3 is going to be negative square root of 3 over 2. So there's plenty of ways to simplify this. You could end up with, let's see, 2 pi minus 6 times the square root of 3 over 12. We could divide all of that by 2, make this 3 and 6. So that is one of our solution points. So all you have to do to get this point is to plug your original answer into your original function. And because I'm going from a negative slope to a positive slope is a relative min. I know that because I'm going from negative to positive. And my second point, which is 5 pi over 3, 5 pi over 3, if I were to plug that in, I would get 5 pi over 6 minus a negative square root of 3 over 2, which would be a positive square root of 3 over 2 now. So that gives me a similar kind of thing. I'm going to get 5 pi plus 3 square root of 3 over 6. And because it goes from a positive to a negative, it is a relative max. So it's just like the testing for whether it's positive or negative, but now you've got to list a little bit more than you did before. Next one we can look at is find the relative extrema of our function. So we've got f of x equals x squared minus 4 to the 2/3. So kind of a weird, strange little function here. But again, we go about it the same way. We're going to find f prime of x. And this one's going to take a second, so you're going to have to do the power rule first. So 2/3 times x squared minus 4 to the negative 1/3. Then you have to multiply by the derivative of the inside, which is 2x. So for this, we end up with 4x. So 2 times 2x, we get 4x over 3 times the cube root of x squared minus 4. So writing it in this way is very helpful for us because we're trying to find all of the critical numbers, anywhere where it's 0 or undefined. So we get f prime of c is going to be 4c over 3 times the cube root of c squared minus 4. So basically, you're going to get a 0 anywhere where this is 0 or this is 0. So I know right off the bat that c could be 0 or 3 times the cube root of c squared minus 4 could be 0. Which, if you solve this out, you would end up seeing that the only way that this is possible is if c is going to be positive or negative 2. It has nothing to do with the cube root. It has everything to do with the fact that the whole thing, this c squared minus 4 would be 0 if c was plus or minus 2. And so we need to go through and find the test points that we want to use. So we've got negative 2, we've got 0, and we've got 2. So we've got lots of points to check. But again, we're going back to our derivative here and plugging our number in. So if we plugged in a number that was more negative than negative 2, so it's like negative 10, we would have a negative on the numerator, but we'd end up with a positive in our denominator, which means that our whole number overall would be negative. Now, for our next number, between negative 2 and 0, we're going to pick negative 1. So this would be a negative. And, oh, well, look what happens here. We end up with a negative number on the inside. Well, that's okay. We can take a negative cube root. There's nothing wrong with that. And a negative cube root would make a negative. So this actually ends up becoming a positive. Not really that big of a surprise if you know how different functions work. Then if we pick the number 1 to go between 0 and 2, this would become a positive. This one would still be negative because you would have x squared minus 4 would be negative. The cube root of that would be negative. So this is a negative. And then we have our final one. I'm sure you could guess we could use 10. And we'd end up with positive over a positive, giving us a positive number. So this is all what our derivative would be. So again, the numbers don't matter, it's just whether it's positive or negative. So we need to go through and figure out, well, what are all these numbers? What would help us find this? So our first number here is going to be negative 2. And negative 2 is, if we plug it back into our original, up here, we should get 0. And that is going to be a minimum. That's because our slope goes from negative to positive. Negative to positive. Now, as we move on, 0 is going to make the cube root of 16. Because we plug this in, we get negative 4 squared, which is the cube root of that. So we end up with the cube root of 16. It's fine to leave it that way. It's also 2 times the cube root of 2, but I'm just going to leave this here. And that is a relative max. That's because it goes from positive to negative. So positive to negative. Then we have our next point, which is 2. That'll also make 0. That is a relative min. And that's it. Those are our 3 different options. So this graph, over this period, this very short period between like negative 10 and 10, it's going down, then up, then down. So we end up with, or excuse me, it's going down, up, down, up. So we end up with 1, 2, 3 extrema, 2 relative mins, and a relative max.